So today we are doing algebraic equations that involve exponents. Okay, so obviously we're gonna have to revise our laws of exponents. First, hi Gwena and somebody saw. Okay, let's revise the laws of exponents. Okay, these are our laws and definitions. Okay, first one is the multiplication law. So if you are multiplying two numbers that have the same base, then you're going to add exponents. I like using color, and when it gets a bit messy, I'll try to behave today. Okay, so law one says you are multiplying, same base, add your exponents. That's quick summary. Law two says you are dividing, again, same base, and in this case, you subtract exponents. Okay, so these are essentially basically opposites of each other if you think about it. Really, not really, but kind of sort of. Law number three is our power to a power. So you have a power in the bracket x to the power of a, or raised to another exponent, which is b. And if my highlighter can cooperate, life would be wonderful. Here we go. Or raised to the power of b. In this case, you multiply the exponents, not to be confused with law number one. In law number one, we are multiplying the bases, okay? Then you add your exponents. In law number three, you have a power to a power. Then you multiply the exponents. You don't add them, you multiply them. So do not confuse those two laws. If you know them well, you don't confuse them as much. Okay, guys? Then we are on law number four. Law number four is the distributive law, which means that you distribute. So we have bases inside the bracket. We have an x and a y, and the exponent that is outside will be distributed. So you give it to the x and to the y. So once you distribute the exponent, you multiply it by the exponent that was already there. So if you look carefully, x already had an exponent of a, and y had an exponent of b. So once you distribute, you multiply the exponents. Hi guys, I see you, even the DMs. Okay, those are our four laws. Now we're going on to definition. Definition one is simple and straightforward. Anything to the power of 0 is equal to 1. Okay, so when you have those long brackets, let's look carefully to see if your teacher's not trying to trick you or something, because all of that to the power of 0 will still be equal to 1. Okay, cool beans. Now this one was a little bit of a fight for us. Let's see if we remember it. This one is a definition for negative exponents. So if you have 2 to the power of -3, okay, we want the reciprocal. Now, the reciprocal, guys, means if you have 2 over 3, the reciprocal would be 3 over 2. So you are swapping the denominator and the numerator, right? So in this case, guys, if you have, 2 to the power of -3 is same as 2 to the power of -3 over 1. So if you want this exponent to be positive, you will then flip it over and have 1 over 2 to the power of 3. Only thing I'm going to remind you here is once you do the reciprocal, your exponent becomes positive. That's the whole point of doing the reciprocal. Okay, that's what we want. We want positive exponents. And I press something that I don't understand. There we go. We want positive exponents. So you do the reciprocal and you will have a positive exponent. Oh, Havana is not happy about writing today. Please tell us how it went. I also have load shedding Zucchini and it's not coming back. And look at my laptop battery. Oh, hectic. Okay, so these are the laws. Before I move on, do we understand the laws? Because we will be using them to solve equations. If you want an in-depth explanation of these laws, we did them. Okay, we did a whole chapter on exponents. I think it was 2 topics ago. So the recordings are available on the website, and we do law by law for one lesson. So you will be able to get it. Okay, I see all thumbs up. If you have a question, you raise your hand. Cool. Now let's apply these laws. Now it's gonna get hectic. Okay. I have so much faith in you guys. I'm actually excited. Let us apply these laws. Remember, we are doing exponent. I actually should have just said exponents in algebraic equations. So it doesn't necessarily mean we have to use those laws when solving algebraic equations. Okay, just means we have to keep them in mind. Okay, so let's keep them in mind. A says a number, nobody knows what that number is, to the power of 2 is equal to 36. What is that number? A number to the power of 2 is equal to 6. What is my number? What have you saying?
Ma'am, wouldn't that number be 6? Because
Yes,
half of 36 is 6.
Ooh, not half. What's the operation we're looking for?
Divide.
No. What's this called?
Squared.
Square root. Remember now. There we go. The square root. Okay, guys. So you did inverse operations on Tuesday with Miss Coco. And I'm sure she explained the opposites and inverses of operations, but I know we didn't really cover this inverse. Let's talk about the inverse operation of squares. If you square root a square number, so if I solve this, it will be the square root of 4, which is equal to 2. That 2 is essentially the same 2 we have over there. Okay, so then we can conclude that the square root is the inverse of squaring. Oh, I should probably write off. Okay, so if you square root a square, you'll just be left with the base number. That's what we did over here. We want y to be on its own. We want this y to be on its own. So we square root to get rid of the squared. So therefore, y is equal to 30. No, not 30. Of course, I'm going to write 36 because I forgot to say something very important. What you do on the left, you do on the right. So if you're going to square root y squared, you have to go and square root 36. So therefore, y will be equal to 6. Okay. Okay, guys, it's not that bad. It's not that bad. Now we are in B, and we're going to have to use one of our laws. Who has an idea? Actually, I think B is a little bit hectic, but let's see if you guys will understand. Nanhlanhla has an idea. Nanhlanhla, what are we doing with that 0? Oh, Tammy knows it's -1. How do you guys know that? I love it. Okay, that is correct, but we need proper way of writing it out. We need proper ways of writing it out, guys. We need a proper way of writing it out. So I think before we do this, I'm gonna have like a little crash course on the side here because I have cheated us and I have not included all the notes that I was meant to include. So now I want to go on the side and I can't, but it's fine. I'm gonna do it here. So guys, if I say to you, 3 to the power of something, we don't know what that something is equal to 3 to the power of 3. Tell me, what is x? What is x? Kanya, please try. I don't know. Someone will be able to. Oh, never mind. The hand went up. There was a hand, but it's gone. Tammy says x is 3. How do we know that, guys? X is 3. If we did this over and over when we did expressions. If we have the same bases on both sides, okay? So 3 to the power of something is the same as 3 to the power of 3. That something has to equal 3 for this equation to work. Do we all understand that concept? If 3, there we go, Emmanuel. Emmanuel was here when we were doing this over and over and over again. So the bases will fall away because the exponents have to be equal. So now we go back here to our lovely number b that we have over here. Number b says 3 to the power of x plus 1 is equal to 1. But now I just said we want the same bases. So how are we going to make these the same bases, guys? How are we going to make these the same bases? Think of your laws. Gwena? Yes, Gwena? Hello? Yeah, I can't hear Gwena. That is not good. Okay, Amira? Hello, Amira, you may unmute. There we go. Never mind, you muted again. Try unmuting again.
Ma'am, are you not gonna add?
No. Remember, we want a base of 3 on the side, on the right side, excuse me. So how can we turn a 1 to something with a base of 3? How are we going to do that?
Times 3.
Think carefully of your laws. Check in the chat. Nonshanta and Boniwe are helping you. How are we going to turn it to the power of 3? Nope, guys. Remember, I said we want a base of 3. So it can't be 1. We want a base of 3. Not the exponent. We want the bases to be the same for the exponents to be the same. Hadassah? Hello? Okay. So, guys, as per our definition, anything to the power of 0 is 1. So we have used that law. We've just gone backwards. So we're making the 1 3 to the power of 0 because we want the same base. Okay, so now we have the same base. We have a 3. We have a 3. What happens when we have the same bases? What happens when we have the same bases? If the bases are the same, no, we are not multiplying, guys. Thank you, Tammy. Then the bases can fall away. So then these bases can fall away. You're left with x plus 1 equals 0. Therefore, x is how much? Yes, guys. Therefore, x is how much? If x plus 1 equals 0, thank you. X is -1. Okay, it seems we are not acquainted with our laws of exponents. I'm going to go back up. Look carefully again, guys. We just use this definition. Anything to the power of 0 is 1, which means if you have a 1, you can make it something to the power of 0. Remember, equations work both ways, okay? That side is equal, the left-hand side is equal to the right-hand side, which also means that the right-hand side is equal to the left-hand side. So that's the law we used. We wanted bases of 3 on the same sides, on the what? On both sides. Whew, guys, talking too much does that too. We wanted bases of 3 on both sides. So on the left, we already had. Okay. There we go. Remember to keep on mute, guys. Okay. So we wanted bases of 3. So in order to make bases of 3, if you have a 1, you can make it a 3 to the power of 0. Okay, guys. Then once the bases are the same, the bases fall away and you can equate your exponents. And that's how you solve for x. Yes, I have to shock you so that you don't get shocked in a test when your teacher tests you. Okay, I have to shock you. Don't worry about it, guys. Let's move on. Okay, let's do number C. Number C is a little bit more forgiving. Who knows how we're going to do number C? Hi, how? Who has an idea of how to do number C? Palisa. Yes, Vanessa.
So, ma'am, since we have the same basis, we're gonna add our exponents. So we need to find x squared. So, ma'am, the opposite of add is minus. So 7 minus 3, which gives us 4, meaning the x is equal to 4.
Beautiful. So first we add the exponents. So I'm going to say 2 to the power of x plus 3 equals 2 to the power of 7. So when we have the same base, what can we do?
We add the exponents.
We're not multiplying.
Oh, when we have the same base, we
On two sides.
minus.
No, not dividing. Look carefully. What did we do when we had the same basis? If 2 to the power of something is the same as 2 to the power of 7, check in the chat, they're helping you.
Ma'am, we cancel.
Yes,
The base.
you can get rid of the
Oh.
bases, right? Because they're the same on both sides. So therefore the exponents have to be equal. So then x plus 3 will equal 7. And then how do we solve it? Take it away from here. Yep, Palisa's gone. Nope, Palisa's still here. Palisa? Oh, okay, Palisa might be having connection issues. It's okay. Tabi saying.
Ma'am, don't you say 7 minus 3
Yes,
would
you
give
do.
equals to x?
Then therefore x will be equal to
4.
Thank you very much. Thank you very much. Ma'am, why didn't you multiply the 2's? Why would you multiply the 2's? They are the same base. So you cannot multiply them because we don't know how much 2 to the power of x is. It could be anything. Okay. So the law, let me remind you of the law, Quizzy. The law said, it was law number 1. There it is. Okay. We have the same bases. We had a 2 and a 2. And we were multiplying. So then you're going to end up with the same base, keep the base, and we add the exponents. Okay. You're welcome. What happens if the bases are not the same? Dumelo, you can't do anything about it. So let me show you. If you have 2 to the power of x multiplied by 3 to the power of x, this is literally just, okay, well, you can if the exponents are the same. Let's choose a different exponent. Let's say to the exponent of y. And this will literally just be 2 to the power of x times 3 to the power of y. You don't know what the value is, so you cannot multiply them, okay? The problem that we have there is the variables. They're the ones that are complicating everything. Because we don't know 2 to the power of x could be anything. Okay. I hope we understand that. Okay, that was number C. Yes, what's happening there by D? Which law can we apply to D? It is an extension of the laws, but is one of the laws. Aliyah. Yes, Aliyah.
Hello, ma'am.
Hello.
I think you used the law of the, I'm not sure of the name, but it's the one with the brackets where you share the exponent.
Yes, Aliyah. So then you're gonna have?
So then you're gonna have x squared over 2 squared.
You are brilliant, Aliyah. You're making my day. Equals 60. So this is the same as x squared over 4 equals 60. Now, how do we get rid of this 4, Aliyah?
We have to times it by 4 over 1.
Yes, but what you do on the left?
You do on the right side as well.
Yes, so these 4's will cancel. So we're gonna have x squared equals, how much is 16 times 4?
64.
64. We're almost done. Almost done. Now the problem to get rid of is the squared. How do we get rid of the squared?
We're gonna square root it.
We're going to square root. Again, what we do on the left.
We do on the right.
So then x will be equal to how much?
8.
Beautiful. That was absolutely gorgeous. The best.
Thank you.
Oh, I love it, guys. I love it. Tammy's hand was raised. Let's hear what Tammy has to say. Yes, Tammy.
Hi, ma'am.
Hello.
Ma'am, I'd like to do E with you.
Oh, you want to do E? You guys are
Yes,
just like
ma'am.
making my day. Let me scroll down so we can do E together. There we go. There's some space. Okay, take it away.
Okay, ma'am. So the first thing we're gonna do is we're gonna divide both sides by 3.
Okay, then we divide both sides by 3. Divide by 3. Divide by 3. These 3's will cancel now. So I'm left
Yes,
with
ma'am.
2 to the power of x equals how much?
It equals 8.
8. Okay, now what?
And then we can write 8 in the form of in the form of its exponents, ma'am.
So what would it be?
Ma'am, it's going to be 2 to the power of 3.
2 to the power of 3. Okay, therefore what?
So, ma'am, because we have the same basis, and then the 2 cancel out, therefore x is equal to 3.
Thank you, Tammy. You guys are making my life. Like at this point, I can go sleep and like I'll be satisfied with life. Whew. Isn't that brilliant, guys? Thank you so much, Tammy. Thank you, thank you, thank you so much. We did, Leah. We did move it. Remember, it was times, so we moved it by dividing it. Remember, it wasn't plus. In the case of here, we had a +1, so we moved it to the other side. But here we had times, so we did move to the other side, but we divided. Yes, I'll do D now, just now for you guys. I want to give Leah understands my explanation. Okay, let's go back to D. We have had requests for D. So with D, what we used was the distributive law. Remember the distributive law said, if you have two bases, x, y, and an exponent, you distribute. So this was multiplication, right? But this law works with division as well. So we have two bases, which are x and 2. Okay, so if we have those two bases and exponent outside, we still distribute. So x gets a square. That's why I don't teach English. X gets a squared and 2 gets a squared. So that's how we ended up with x squared over 2 squared. So that was step 1. Okay. In step 2, I simplified this 2 squared and just made it a 4. All right. Then I asked, how do we get rid of a 4 if we have an x divided by 4? So you would have to use the inverse of divide, which is multiply. That's why we said times 4 over 1 on this side, and you times 4 over 1 on the other side. These 4's will cancel out, so we're left with x squared. This was x squared. And then on this side, we had a 16 times 4. So then, after you do that, we'll go to the bottom a little bit. After you do that, we're going to say, how do I get rid of a squared? And we said the opposite or inverse of squared is square rooting. But what you do on the left, you have to go do on the right. So these two operations will cancel each other. You'll be left with x, and the square root of 64 is 8. Okay. You're welcome. You're welcome. Okay, then the hands that are up, I'm assuming they are questions. Inati.
Ma'am, I can't see your screen.
Oh, geez. Please DM Simone. She'll be able to help you, okay? You've missed quite a bit, though. but you can watch the recording of this lesson when it goes up, okay? Okay, let's hope Inati heard that. Everyone who's unmuted, please mute yourself. There are a lot of people who are unmuted. I'm not sure why. Okay, Luandiswa, do you have a question?
Yes, ma'am. I would like to know. I would like you to please do E again for me.
Okay, I'll explain E just now. Let me just hear what the typing has to ask. Don't put your hand down, okay?
Yes.
Oh, ma'am, I breathe.
Okay, typing, what are you saying?
I was just wondering if you can please redo. I was wondering if you may please redo D, ma'am.
Oh, I just
Yes,
did.
ma'am.
Did you miss it?
Yes, ma'am. I joined like late because I had to leave because like the connection was bad, so I had to ask my mom to hotspot.
Okay. Okay. Okay, let's first deal with E with Landisa. Okay, Landisa, unmute for me, please, so that I can check that you're with me. Landisa, are you there?
Yes, ma'am.
There we go. So with E, we had a 3 times 2 to the power of x equals 24. You see that?
Yes, I'm here.
That dot is the times. So we started by getting rid of the 3 that's in front of our number with a variable. Remember, we
Yes.
want the variable to be on its own, right? So you get rid of times by dividing. So that's what we did in step 1. We said 3 times 2 to the power of x divided by 3. Oh, so you do it on the left, you have to go do it on the right. So that equals 24 divided by 3. So these 3's will cancel each other out. Okay, gone. So you're left with 2 to the power of x, and 24 divided by 3 is 8. Okay? But we want the same base. And if I have a base of 2 this side, that means I want a base of 2 on the right. So we wrote 8 as 2 to the power of 3. You see that? This is terrible, this arrow. So we rewrote 8 as 2 to the power of 3. But we said when the bases are the same, the exponents have to be the same. So that's how we ended up with x equals 3. I hope I have helped you out.
Yes.
Okay. Here we go. I'm just going to assume I helped you out. Okay. And I'll be saying one more time with number D. You just, first step, we distributed the exponent. There's a law of exponent. Distribute the 2. So then you have x squared over 2 squared, okay? Then you have x squared over 4. We want to get rid of the 4 that's in the denominator, so we multiply it by 4. That's what we did over there, multiply it by 4. But if you multiply by 4 on the left, you multiply by 4 on the right. Then you're left with x squared equals 64. To get rid of the squared, we square rooted. What you do on the left, you do on the right. That's how we ended up with x equals 8. Okay. Question E, 3. It is like that. Okay. Where does the 8 come from? It comes from 24 divided by 3. Remember, we divided by 3 on both sides, guys. That's where the 8 comes from. Okay, let's do a brain break. Let's do a brain break. It's going to be a very quick one, apparently, because people have already seen this before. What is the top view for this shape? Questions, not questions, excuse me. Hands went up so much. There was like, you're welcome, to be saying. Indipile. Nope, Indipile has vanished. Kwezi.
Ma'am,
It's a triangular prism.
But which one is the top view? Is it A, B, C, or D?
The top view is C.
How do you know that?
I just looked at the
spam
colors.
the chat. Let's not spam the chat, guys. Okay, I'm gonna block the chat until we listen. Quizzy just guessed. Quizzy's like, I think it's this. That's not good, Quizzy. That's not good. Let's hear.
Remember, I looked at the colors.
Oh, okay, Quizzy.
Hi,
Guys,
ma'am.
hi, hello. How did you figure out that it's C? I'm guessing you're gonna say it's C.
Yes, maybe it's C.
Okay, how did you figure it out? Give
Ma'am,
us some-
because of like the color. Because when you look at it, yellow is like in the front, then comes green, then red, then green again.
Okay. And then right next to the green is a green, and then a red, and a blue, then a yellow. And indeed, it is C. Beautiful, guys. Our answer is C. This was too easy for you guys. I should have gotten like 5 of these, but it's fine. Next time I'll catch you guys. Okay, and then the last one. What is the number under the parking spot? What's the number under the parking spot? Anyone? Someone? Someone says 78. 78 with a question mark. 87, I think 78. Ooh, a lot of people are saying 78. Some say 87. Tammy's saying it's like it's 0. Straight up 0. 28, 26, 87, 78. Ooh, Tegan. Let's see what Tegan has to say. 58, 96, 182. Yes, Tegan.
I think it's 87.
How did you figure it out, Tegan?
Ma'am, because I just ma'am, and
You
that's
just
87. It should be 87, ma'am.
said you what? We lost you for a second there.
Oh, sorry, ma'am. I said I flipped my phone, ma'am.
Beautiful.
Upside down.
Man. So if you flip your phone, guys, this is 86, 88, 89, 90, and 91, which means this one will have to be 87. Nice. At least this one wasn't that easy, right? At least this one wasn't as easy. Okay. It's a number we don't know. I love it. I love it. I love the responses. Leah, don't drop your laptop, please. Don't drop your laptop. Leah's like, I want to say there's no number. I don't think there's a number at all. You guys don't actually trust me. Like, you guys genuinely thought I gave you something without a number. I better drop her phone. I'm sorry, guys. Who still has a desktop computer? So you have to flip the keyboard with the wires and everything to see it. I started calculating and stuff. You guys don't trust me. I knew 6 was too good to be true. Okay, guys, I'm sorry. I beg thee for forgiveness. I beg thee for forgiveness. You guys are calculating. This is so adorable. This is hilarious. Stand upside down. Simone, are you seeing this? Stand upside down. Just stand upside down. It'll solve all your problems. No forgiveness for me. I guess. Do a headstand or for a brain break and break your bones. Woo. As a person can drive and move the car. You guys are hilarious. Actually, I'm over this. I'm done. I have to take a screenshot of that response. Is there someone who can drive and move the car? I can't believe it. I actually can't believe it. I want to show my bosses the creativity that we come up with in this class. I'm sure they'll be proud of me. Oh my goodness. Okay, guys, let's continue. Let's continue. Whew. Wow. Wow. I can't believe it. Okay. Of course, I wasn't gonna let you guys off easy. Who's gonna do A, B, and C with me before we go off and do our quizzes? I did volunteers for A, B, and C. You guys were right not to trust me. You guys were right not to trust me. Simone was having a good time in the chat. I can't even.
I am. The responses are so funny.
They're hilarious. You guys are funny, man. You guys are really funny. You don't trust me anymore. You guys were right not to trust me, guys. So help me then with A, B, and C. Okay. I'm gonna assume everyone whose hand is up is helping me with A, B, and C. So if you were gonna answer the brain break, please put your hand down now, because I'm gonna pick on you to answer one of these. Tammy's hand is still up. Let's go for it, Tammy.
Ma'am. Okay, ma'am. So, ma'am, I'll do A with you.
Okay, let's go for it.
Okay, ma'am. So the first thing we're going to do, ma'am, we're going to cube root 1000.
We're going to
Cube root 1000 because on the other
cube
side, ma'am,
root
it's 2x to the power of 3.
Okay, cube root. Here we go. There we go. Okay, so the answer is gonna be
Ma'am, it's going to be 10.
2x equals 10. And then
We're going to divide both sides by 2.
divide by 2, divide by 2. Therefore, x is
5.
Thank you, Tammy.
Pleasure,
Thank you
ma'am.
very much. These were beautiful. We cube rooted Melobushe to get rid of the cube. Remember when we had a square, okay, I hate using 2 because there's too many 2's when we're squaring. Let's say we have a 5 squared. We can square root it to get rid of the square. So then the answer will just be 5. Okay, so in this case, we had a cube, forget the question, all of that cubed. So we want to get rid of it, and that's why she said we cube root it. Okay, beautiful. Okay, let's hear if everybody who's left wants to help me or has a question. Yes, and Tabi saying.
So can't you also say like, don't you like, I thought that you like distribute the squared, like you say 2 to the power of 3 and then x to the power of 3 and then like you simplify it, or I guess like you answer like 2 cubed and then yeah, that's what I thought you did. Can you do that?
Yes, you
And
can.
then you do the same.
Because you would get
Okay,
that, right?
thank you.
And then you would divide both sides by what?
Yes, ma'am.
So we divide both sides by 8.
2.
Remember, by this one. So then you get x cubed is equal to 125. Then you cube root the end. Then therefore x is 5. That is perfectly fine. You can do it both ways. Thank you, Tepse, because that's the way I thought about it. Okay, that was my first go-to method. Yes, Twenga as well. You guys are brilliant. That's how I started. That's how I thought about it. So Tammy just gave me a very new way of doing it, and I am impressed that you guys are seeing so many methods. I love it. So this is A still. This is method 2. Method 2. And this was method 1. Don't worry, guys. I'll give you guys a chance to screenshot these, okay? End of the lesson, I'll be staying to screenshot. Who's doing B with me? Okay, Fatima, do you have a question?
Yes, ma'am.
Okay, let's hear.
Ma'am, it's about A. Where did you get 5 and where did you get 8?
Where did I get 5? Okay. These are two different methods. You know that, right?
Yes.
So this one is here. We got 5 because we cube rooted both sides. So to get rid of a cube, you cube root. You see that?
Oh, okay. 3 was cubed.
Yes. Okay.
Well, yes.
And then in the second method, we got 8 by saying 2 cubed, because that means 2 times 2 times 2. You see?
Mm.
There we go. Did I answer your question?
Yes, ma'am. Perfectly.
Okay. Wonderful. Let's hear what Sanda has to say. Yes, Sanda.
Ma'am, can I do B with you?
Okay, let's do B.
So, ma'am, you're gonna take the -9, and then you're gonna put it next to the 166, which becomes positive.
Okay. Equals 166 plus 9. Okay.
And then it's gonna be 7.5x equals 175.
Okay.
And then you're gonna divide it by 7 for both sides. And then it's gonna be 5x equals to 25.
Mm.
And then x equals 5.
Okay, so let's just say 5x equals 5 squared. Therefore, x is how much?
5.
If 5 to the power of something is the same as 5 to the power of 2, then x is
25.
base are the same. So the exponents are the same. Therefore, x has to be 2. Do you see?
Okay, ma'am.
Remember, the x is not in the base this time. It's in the exponent.
Okay, ma'am.
There we go. Thank you very much. That was brilliantly done. Thank you very, very much for assisting me. Do we have questions about that one? Do we have questions about that one? Okay, hands just went up. Zuleika, do you have a question?
Yes, miss.
Mm-hmm.
Miss, I don't understand B.
Okay, but where exactly did I lose you?
You lost me when you started dividing the thing by 7. How did you know that you have to divide the thing by 7?
Because dot means times. This is not a comma, it's a dot. Okay. So you get rid of the times by?
By 7.
But how do you get rid of a multiplication? You
Put a dot.
divide. Do
Or
the
you divide.
opposite. So that's why we divided by 7. You see?
Yes, miss. Thank you.
You're welcome. Palisa, do you have a question?
Yes, ma'am. Ma'am, where did a +9 come from?
It came from, do you see we had a -9 there?
Oh, from the side, and then it moved across. Okay, no, ma'am, I didn't see it.
Okay, beautiful. Maybe I should start writing the questions first. Let's hear what Kwezi has to ask. Kwezi?
Ma'am, you confused me like at the end when you said x is equals to 2. Like, how is 5 to the power of 2 equals to 2?
No, not 5 to the power of 2 equals to 2. X is equal to 2. Look, I already wrote it at the bottom here. Now. Kwezi, if 5 to the power of something that we don't know is exactly the same as 5 to the power of 2, that means x has to be equal to 2. Do you get it?
No, I don't.
Okay, why is it confusing you? We have the same basis, right?
Yes, ma'am. Oh, okay.
So remember what I said? I think you're confused because you're thinking of when the x is in the base, which is not. Right now, the x is in the exponent.
Okay. Thank you, ma'am.
Saying, there we go. You're welcome, Kwezi. Thank you for your question. Let's hear what Dumelo says. Dumelo?
Hello, ma'am.
Hello.
Hi, ma'am. It's fine. I now understand.
Okay, beautiful. Let me ask Hello. Hello.
Hi, ma'am.
Hello.
Ma'am, I wanted to ask about A.
A. Okay, let me
Yes, ma'am.
2 seconds to scroll up. There we go.
Ma'am, I wanted to ask where we got 10/2 from.
Okay, do you understand how we got to 2x equals 10?
No.
Okay, let me go to the side. Okay, actually, let me rub it out. Let me rub it out and show you how we got there, okay? In 2 seconds, we're going to be done just now. Method 1. So the question was 2x to the power of 3 equals 1000. So we've been getting rid of operations by doing the opposite, right?
Yes.
So what is the opposite of cubing? The opposite of times is divide. The opposite of add is subtract. So what is the opposite of cubing? If you're cubing to the power of 3, what's the opposite of that?
Is it square rooting?
Well, it's cube rooting. You're almost there. It's this one. You see?
Yes.
So that's what we did. We wanted to get rid of this cube over here. So we did that by cube rooting. Because they're opposite, they will cancel each other out. Do you understand that?
Yes.
So then we went and cube rooted both sides. Cube root, but what you do on the left in an equation, you have to do on
the right.
That's why we cube rooted both sides. Do you get it?
Yes, I get it.
So then this cube root on the left will cancel out with this cube on the left. So what's left is going to be 2x. And then if you check the cube root of 1000, the answer will be 10. Because cube root means what number do you multiply by itself 3 times? And the answer is 10. 10 times 10 times 10 is 1000. Are you with me so far?
Yes, I am.
Now we want to get rid of this 2 that's in front of the x. How do we get rid of multiplication? Remember, we're doing opposites. So what is the opposite of multiplication?
Division.
We divide. So we divide by 2. But again, what you do on the left,
you also do on the right.
So then this 2 that we divided here cancels out. Do you see that?
And we're left with x.
We're left with x. And what's 10 divided by 2?
It's 5.
Do you see now where we got it?
Yes, I see.
Beautiful. That is wonderful. I hope I helped you. You are welcome. Okay, Noko, you are up next. Hello. Noko, you can unmute. There we go.
Hi, ma'am.
There we go. You have a question?
Ma'am, I got yes, ma'am. I got confused on where you added the cube roots on both of the equations by A.
Do you understand why I'm adding the cube roots?
No, ma'am.
Okay, let's check here. Let's say 2 cubed. How much is 2 cubed?
It is cubed. It is 8, ma'am.
8. And then what's the cube root of 8?
The cube root of 8 is 512.
Cube root, not the cube. So you do the little symbol that says cube root. Yes.
Cube root. Ma'am, it's 2.
You see that these operations are canceling each other. We are right back to 2.
Yes, ma'am.
You see that?
Yes, ma'am.
So if you say
Yes, ma'am.
2 cubed and you cube root it, you're basically canceling out this cube root and this cubed. So then you're left with just 2. So we had a cube there and we wanted to get rid of it. Do you see now why we cube rooted?
Yes, ma'am.
There we go.
Thank you, ma'am.
You're welcome. Guys, anyone wants to do C with me quickly? Anyone has done C while we were waiting? Anybody? No? Nobody? Ha! Hands went up. Spanelo? Spanelo? No. Tammy? Let's hear what Tammy has to say.
Ma'am, can you do C with you?
Yes, let's go for it.
Okay. So ma'am, I think the first thing you're going to do, you're going to multiply it, both sides by 32.
Okay, you want to multiply both sides by 32. So then we're going to have 2x equals 2 to the power of x 3 times 32. Okay, then what?
And then we're going to have 2 to the power of 3 plus x equals to 6u. Ma'am, is it going to be 64 x to the power of 3?
You're not allowed to times them. First, do this. Power to a power. How do we do that? What do we do to do the exponents?
Ma'am, we multiply them.
We multiply. So it's 3 to the power of x times 32. What's our big problem here, Tammy?
Ma'am, I think it's the 32, ma'am.
32. We want something to the power of 2. Can we not get 32 to be something to the power of 2?
Yes, ma'am, we can.
Can. 32 is the same as what? 2 to the power of what?
Ma'am, it's 2 to the power of 5.
Thank you. So it's going to be 3x times 2 to the power of 5. Doesn't this look a little bit better?
Yes, ma'am, it does.
Okay, now what?
So then we're going to cancel off the bases because they're the same. So we're going to have 3 plus x is equals to 3x plus 5.
Okay, let's first do the adding step. So I'm going to say 3 plus x equals 2 to the power of 3x plus 5. Then we cancel bases. So then 3 plus x is equal to 3x plus 5. Now, how do we solve for x?
Then so we can transpose the 3x to the left, then it's going to be x minus 3x, and then transpose the 3 to the right hand side, it's going to be 5 minus 3.
Okay. Still going lower. Oh, I had more questions about those. Okay, so then you said it's going to be negative 2x.
Yes, ma'am. Negative 2x is equals to positive 2. And then now we're going to divide both sides by negative 2.
So then x is?
X is equals to negative 1.
Brilliant, Tammy. That was brilliant. That was brilliant. Thank you, Leah. That was brilliant, and that is how we end off our lesson today. all the best with your quiz. You guys may go. I'm going to answer Olerato's question. If you want to stay, you may. Okay. But I'm going to answer Olerato's question just now. Everybody who feels like they understand, enjoy the quiz, enjoy your evening, enjoy everything in your weekend, and be safe. Okay. Olerato said, how did you get 2 to the power of 5? We changed 32 to something with a base of 2. So we made it 2 to the power of 5. So you go on your calculator, remember, say 32 equals, you press shift, and the button that has a fact on top. That's the one with the commas and semicolons and what's this one. And that will tell you that 32 is the same as 2 to the power of 5. Okay? Can I make it simpler? Not really, no. Not really. You still have to change 32 to 2 to the power of 5, okay? Bye, guys.